Okay, excellent. I think we'll begin. Well, thank you everybody for joining us today on this webinar around protecting your web applications, in particular around formjacking, e-skimming and Magecart attacks. We'll get started straight away, so I'll pass over to you, Avatar.
Okay, so thank you very much. It's a pleasure to be here. My name is Avital Gushkovsky. I'm co-founder of Source Defense, and I'm happy to be here to talk about formjacking and Magecart. The main purpose of this webinar is to explain the problem, where it's coming from, and who might be vulnerable to this, and maybe break some of the misconceptions around this. So I'm going to jump right in. Formjacking and Magecart. Formjacking and Magecart are attacks happening on the client side of your website, meaning it's happening on the browsers for your users, and it's happening through client-side scripts or JavaScript. Client-side scripts, which we use today to either make the job of development easier with frameworks like React or jQuery, with open source libraries, or with marketing tools meant to increase user engagement and help monetize off our website. To try and understand why these tools are a problem for us and why they are so dangerous, we need to consider what's happening to us as users when we try and go on a web page. So let's say you are now going to your favorite e-commerce website and you want to buy a product. What will happen is that your computer will call a web server. That web server will return HTML back to your computer. At this point, you've covered the entire security perimeter of the website. Your call was encrypted using SSL. You went through a firewall, a WAF, and probably a few other initials. And now everything is happening locally on your computer. At this point, your computer is going to call content delivery networks or CDNs and open source library servers. It's going to contact the third-party services, which might call fourth-party and fifth-party services. And all of these are going to send JavaScript back to your computer. Now, it's a common misconception, but it is a misconception that the origin of JavaScript has any effect over the level of access that script will have to a page. But in fact, it doesn't matter if a script came from a third-party service, an open source library, your CDN, or even your own web server. Any script on the page can do anything to the page and with the page. Any script can take the users to different pages, change the content of the page, access every field, every form, and even record keystrokes while your users are typing in a username, password, credit card information. Now, this all is happening in an environment that is not only not secured, it's not even properly monitored. Now, this is not an indictment, because if you think about it, how do you even start monitoring for these things? And I assume what I will tell you now happened to you all as a user. When you went to an e-commerce website, you looked at a product that you find interesting, whether you bought it or not is irrelevant, you will now see an ad for this product wherever you go. The reason this happens is because these tools, they know how to identify you and they know how to react to you as users. Now, the same way you can target an ad to a user group, you can target a hack to a user group, making it very, very complicated to try and monitor and control what these scripts are doing on the pages. Now, I want to take a moment and talk numbers or statistics. At Source Defense, we have a threat report tool that we use to analyze a website. That tool will map the scripts on a page, and more importantly, it will map what these scripts are doing on a page. So we've taken the data of 1,000 threat reports made on e-commerce websites and kind of refined that data to see the trends. So the first thing we're going to look at is a map of just how script loads on pages. So we can see, and this is a real example of a real website, we see the main site loading a tag manager platform, which is fairly common today. That tag management platform allows the marketing teams to add third parties to the page. These might bring in fourth parties and even fifth parties. We also see some of the tags deployed directly on the page, for example, New Relic. An interesting thing about this specific map and why I chose it as an example is that this website is using New Relic as their analytics platform. Now, obviously, I can't know this for sure, but in my experience, if a website chose to use New Relic and not Google Analytics, it is a conscious decision to not allow Google access to their pages. Why? Because they don't want their data shared with Google. And again, I assume this because Google is a very good free tool. And if you made a decision to use another tool that actually costs money, that's usually the reason. So what's interesting for me here is that they are working with New Relic, but their tag manager puts on Taboola on the page, who brings in Solvay, who brings in Google Analytics. This means that even though they didn't want Google to have access to the page, Google still has full access to the page. And it is very likely that the website owner doesn't even know this is happening. They don't know Google is here. Another interesting data point that we found when we looked at the accumulation of the reports is what types of scripts are running on e-commerce platforms. For the most part, over 60% of script running on e-commerce websites are advertising, analytics, and marketing tools, meaning these are scripts that only need to read the content of the page and save a cookie. But if you look at what scripts are actually doing on pages, then almost 70% of scripts running on pages will access forms and input fields, or even listen to form submission, or every link clicked on a page. So this is not malicious behavior, probably. It is more an abuse of power. These scripts have full access to the page, so they abuse their power to do whatever they want, to get the most information they can, so they can use it to monetize later. If you want to know what these scripts are doing on your pages, you can scan this QR code or just go to sourcedefense.com/check-your-exposure, and you can get a free risk assessment of your own website. Now, I want to show you a demo of a hack. Okay, this demo simulates fairly closely to one of the very well publicized attacks used by Magecart, and we'll go a little deeper into it in a few minutes. So let's see what we have. I have a domain called ihacker.me. This is owned by Source Defense, and all it will do is that it will show you any information sent to this website in a simple table. As you can see, it is empty now. I'm refreshing. There's no data here right now. Now, let's go to Headphone City. I've already created a cart in Headphone City. This is one of my favorite sites to buy audio equipment. So I'm going to fill the form and try to make a purchase. Before I put in my credit card, I want to make sure I'm secured. You can see the lock icon, and you can see that my connection is secured. And this is a site I frequent. So I'm not really worried. I'm going to provide my information, and I'm going to make a purchase. Now I click place an order, and I'm done. In a few days, I'm going to get my headphones. But if I go to headphoncity.com, sorry, to ihacker.me, and I refresh, you can see every bit of information I put in Headphone City was sent to the hacker's domain. And there was no indication that there's anything wrong on the page. Okay. We'll go a little to more details in a few slides. But we've explained why these scripts are a problem, and I've showed you how I can use client-side JavaScript to hack a website. But is it actually happening today? So honestly, I have thousands of examples. There's the very big hack that happened on Amazon S3 around the end of last year that affected 19,000 websites. There was a hack on Magento that affected 2,000 e-commerce websites just last September. And not to mention British Airways were just fined, what was it, 20 million British pounds just last October over a Magecart hack they have it. But let's take one example and dive a little bit deeper into it. The example I chose is the attack on Ticketmaster UK. The reason I chose this specific attack, well, two reasons actually. The first is that we know a lot about this hack technically, and this is a very technically interesting hack. The second is that this hack basically is what opened up the whole Magecart can of worms, if you will. This is what made Magecart so very well public. But let's start with the technical. So Ticketmaster were using a chat service called Inventa. And the hacker group that hacked Ticketmaster hacked Inventa. And they added 15 lines of JavaScript to the main code sent by Inventa to their customers. These lines did only two things. They checked to see, is the Chrome DevTools now open? For those of you who don't know this, Chrome DevTools is a tool within Chrome that allows you to monitor your network traffic. It allows you to see the elements on the page. It's a fairly powerful diagnostic tool. So if the Chrome DevTools is open, the hacker code remained dormant. It didn't do anything. The second thing the code checked is, are we now on a payment page? If the user's on a payment page and the Chrome DevTools is closed, then what happened is that an additional file was loaded, this time from the hacker servers, and that file gathered every bit of information inside any input field on the page, just like you saw in my hack demo on Headphone City. And when the user clicked place an order, that information was sent to the hacker servers in parallel to being sent to Ticketmaster. Now, Ticketmaster had no reason to suspect anything is wrong. They had no indication there's a problem. They didn't push out a new version of their website, so they didn't need to do any tests, which is why this attack managed to run for a fairly long time. So how long do you ask? When this attack was actually investigated, we found that this attack was active on around 800 e-commerce websites and was active for almost 3 years before it was detected. Now, that is a very long time to be hacked. No surprise, not long after this, Symantec decided to rebrand this attack vector from Magecart to Formjacking, which is suitable. Magecart is basically named after the hacker group that used this. Formjacking is a suitable name for this attack vector. And they declared this is the #1 threat right now for websites. This is the first time anything went above ransomware in about 5 years. Now, we have a lot of interesting data points in this slide. For example, almost 5,000 websites are attacked each month. But for me, the most interesting data point on this slide is the bottom one. $250. You can buy a JavaScript sniffer on the dark web for as little as $250. This means my 14-year-old daughter can do this with less than 6 months allowance. And honestly, she thinks I'm cheap. So before we move on to some ways to try and mitigate this problem, let's talk about the misconceptions, the common misconception about Magecart that we've proven completely irrelevant here. First is that this is a problem for big websites, which is actually in this attack vector, basically the exact opposite. Big websites are a problem, have a problem because someone targets them. Here, when we have an attack vector targeting vendors and using those vendors to get to website, basically any website is at risk. There's a big chance for small and medium websites to be affected. Second is that your WAF, firewall, RASP, or any other initial can help you solve this problem. This problem is happening on the client side, on the browser, meaning it doesn't matter how good your security layer is on your server, on your connection. Once the problem starts when the web page has generated, and this is where you need to focus. This is also not a problem with legacy code. If you keep patching your software, this is not going to prevent this problem. Honestly, the reason British Airways were hacked is because they updated an open source library they were using, and that update brought in the hacked code. And last, it's probably not a question of if you're going to be affected with formjacking. It's more of a question of when, and more importantly, are you going to be ready to protect against this attack vector? So let's talk about mitigation options. I'm not going to talk about companies that are mitigating this problem. I'm going to talk about technologies. Okay, there are around 3 technologies out there today trying to mitigate this problem, and I want to talk about them. The first thing I want to talk about, though, is subrecious integrity, or SRI. The reason I'm talking about this first is because this is very highly advocated as a solution for this problem. And the way I understand this problem, and the way I understand the landscape, this is probably the worst solution you can use. And I want to explain why. SRI, or subrecious integrity, basically allows you to create a hash from a JavaScript file. And then when you load it, you can tell your browser, if the hash doesn't match the file, don't load the file. This is ironclad, bulletproof for change control. You can't get around it. It's a browser level security. But if you want to implement that on external JavaScript files that you don't control, here's what you're going to need to do. The first thing is you're going to need cooperation from whoever owns that JavaScript, meaning every time they push out a new version, you need to know about this and you need to be ready for it. You're going to need to create a new hash and you're going to need to push out a new version of your website, unless you can somehow automate this. And if you've automated this, then basically you're now willingly allowing changes to go through. So why do you even need change control? But the big problem, the way I see it, is the fact that, and we've talked about this when I showed the problem, when I saw the page load flow, these services, most of these services may change from user to user. This means that the JavaScript returned from their servers will change from user to user. Now, how do you hash a dynamic JavaScript? You don't, which is why SRI is not a good solution for this specific problem. So let's talk about the three technologies / tools that are actually being promoted today. The first is detection tools. This is a fairly simple concept. You have a robot scanning your website remotely, trying to identify what's happening on the page. The scan happens once a day or once a week or once a month. I guess it depends on the subscription you've created. And if there's a problem, then you know about it. Or if they find the problem. Obviously, it's fairly hard to find these problems if the code can change from user group to user group. And I'm pretty sure hackers will have a way to detect robots and remain dormant. I mean, honestly, there's a whole industry around bot blocking. But let's say you can get a hack. You can actually find it. If you found a hack, then you now need to respond to it. You need to remove a tool from your page. You need to alert your users there's a problem. You need to alert the proper authorities. You've already been hacked, so you need to instigate incident response, and you have a compliancy issue, and you are probably going to get fined. So it will help you maybe know about your problems sooner, but it's not a good solution the way I see it. The big advantage of this is it is instantly deployed. There's no integration needed. You just sign up for a service. But it's completely external and non-actionable. The next technology is content security policy. Content security policy might be one of the most advocated technologies out there to solve this problem. Okay? Basically, content security policy is a whitelisting solution. You will tell your browser, you will whitelist a list of domains that you allow to load files from and that you allow network traffic to go out to. In that whitelist, you will also specify, can this domain load scripts, open iframes, or load CSS files? The problem is, it's not going to control whatever these scripts do on the page. So once you've whitelisted a JavaScript, whatever it is it will do on your page is completely out of your control. Now, if you search Google for Formjacking hacks or Magecart hacks and go through the first 2, 3, 4 pages, you will find that almost every one of these hacks happened through either a third-party script used by a website, an open source library, or some other form of injecting that code through their own CDN. There are hardly any hacks out there that we can see happening through fourth-party services or fifth-party services, meaning if you have content security policies, these hacks would have happened through services that you would have had to whitelist. Because obviously, if you didn't need these tools, you wouldn't put them on your pages. If they're on your page, you're going to whitelist them. Now, if you've also allowed them to open a foreign iframe, which for almost every tool you will have to, otherwise they will simply not be able to work, then it's very easy to exit the content security policy cage and just do whatever you want inside that iframe that you control. Last, we have JavaScript proxy. This is not a technology per se, this is a method. What you do is you overwrite a native JavaScript command and replace it with something else. So let's take a simple example, a made-up example. Let's say there's a command called fetch that will get you a value of an input field on a page. What you do is you overwrite what fetch does, and you tell it, instead of bringing me the value of an input field, I want you to check the structure of the value and to see if it matches a credit card structure. If it matches a credit card structure, don't give me the value, give me a redacted value. But if it doesn't match a credit card structure, then give me the value. It's a fairly simple concept. It's actually nice and elegant. The problem, the way I see it, is, well, there's not one way to get a value of an input field. There's actually not 10 ways. There are probably 1,000 ways. You can do a lot of things in a very different way on JavaScript. So unless you figure out a way to predict any possible way for a hack to try and get your data, then you're basically signing up for a very long game of whack-a-mole. Not to mention that when you proxy your JavaScript, you risk breaking some of the tools running on your pages because they rely on very specific actions and activities from your JavaScript. So I want to take a minute or two and also talk about the Source Defense client-side security platform. Source Defense was lucky enough to not decide that this is a problem that needs solving a year and a half ago, 2 years ago, when it started getting press. We've actually identified this problem years ago, actually as far back as 2012, which gave us a very long time to create a PLC, form a company, and then create a solution that is designed to solve this problem and is patented. So the Source Defense client-side security platform is built out of 3 main components. We have our insight and management platform. We have our Vice engine that will secure all your third-party scripts, all your marketing tools and chat services and analytics. And we have WIP, which will manage all your first-party scripts, your own internal JavaScript, your open source libraries, basically everything executed on the page. And the idea behind this is actually fairly simple and elegant. It's access policies. You have this on your mobile phone today. When you install an application, if it wants to access your contacts, you need to allow it to access your contacts. So why shouldn't we have the same thing online? Why not say, this open source library, I need to use it, but there's no reason for it to run keyloggers. Or this analytics tool should be able to read the content of my page, but should not be able to write to it. And this is how this is done. Okay, if we look at the flow of loading a web page, we start out fairly similar. Our computer will call a web server and we'll get HTML back. That HTML will include the Source Defense client-side security platform. Now, what will happen now is everything will happen on our machine, on our browser. And the Source Defense client-side security platform will start managing external JavaScript execution. It will allow the calls to your CDN and your open source libraries. But when these scripts are executed on the pages, it will manage their access. It will not allow them to access any editable fields. So no input fields, no forms, nowhere where your users will put in their private data or credit card information. It will also monitor for every external script call on the page. And if you have any third parties executed, it will manage those third parties using the Vice engine. This means we will create what we call virtual pages. The virtual page is an actual reflection of the original page, but we redact anything the third party is not supposed to see. So let's say that your chat service, like in Ticketmaster, should be able to read the content of the page, but you don't want it reading PII or PCI information. So these fields will simply not be on these virtual pages. the third parties will execute on the virtual pages, and we will then look at the HTML end result of what they did on the page. Now, if what they did on the page is in line with their access policies, we will move that to the original page so the user can have access to it. But if they did something they're not supposed to do, let's say your analytics tool just added a layer above the page, you're not supposed to be able to change the content of the page. So this will not be moved to the original page. The user will never see it. And we'll send a report back to the Source Defense Cloud service saying, hey, analytics tool on site X just tried to change the content of the page. This is the HTML element they added to the page. And now you can go back at the Source Defense dashboard and analyze this data. So this means that we have a browser working in a client-side risk environment, which we completely isolate from every external risk and protect, extending your security perimeter from the server to the client, making sure your user activity is both enhanced and secured. Before we get to questions, I'll mention one more time, there is a free risk assessment that you can get from our website. You can either scan the QR code or go to sourcedefense.com, check your exposure. If you put in the promo code E92SDI, we'll also provide a free proof of concept for anyone wanting a proof of concept. Just a word on the proof of concept, and I know I'm ending the end of our time. So we actually enable a completely code-free PLC environment, which will allow you to check our platform without involving your R&D.coms at all, but still see how our platform and your website will behave if it were deployed. Thank you, and very happy to take any questions.
Smashing. Thank you very much, Avatar. That was fantastic. I had a couple of questions in. Obviously, as you mentioned, certainly running the POC, there's no impact on the code. But in terms of kind of running source defense alongside people's kind of existing protective measures, things like web application firewalls, how well does it sit alongside that? And is there kind of any impact on performance of running an additional tool on it?
So that's a very good question. As far as external tools, the source defense tool is agnostic to all third-party or open source libraries. We don't require any adjustment by them, and we do not interfere with them. We actually have a machine learning engine that identifies the best policy for a tool, meaning the strictest policy possible without breaking it. And we send that as a recommendation for our clients, because honestly, you don't want to have anyone choose whichever policies they want. As far as performance is concerned, well, performance is a very complicated issue, obviously, but the source defense has one line of JavaScript at the top of the page that is synchronous. We allow our users, our clients, to put them on their own CDN, so it's not going to be a big delay. And from that point on, engine is pretty seamless. You actually don't notice it running. You actually might even get a performance improvement, but that's not part of our value proposition, simply because of depending on which scripts you have on your pages. If you have a lot of synchronous scripts, then we will isolate those in the virtual pages, meaning they will not be delaying your page if they have any outage problem.
Perfect. And then just a question with regard to the user experience. Obviously, kind of this is all about kind of providing additional protection and working out where their kind of exploits may be made against vulnerabilities with those third parties. Obviously, from from the organization side, it's about getting that visibility and having kind of reporting in the back end. What is there any kind of engagement? Is there any impact on the end user experience in terms of their visibility and things are going wrong, or kind of being able to understand what's happening, or is it just about kind of taking all of that risk away from them, so it's as clean as possible?
So that was our main focus. The whole point is that the user never knows what's happening. Everything's in the background. And even for the website managers, we don't, and this is very different from any other security tool out there, I think anywhere, we don't break a third-party script or an external library if it's trying to do anything wrong. We don't stop its activity. We simply evade what you don't want happening. So as long as the hacker didn't break the tool you're using, you're actually still going to keep on monetizing off this tool, getting the value you want to get for your users without taking on anything you don't want these tools to do.
Okay, that's brilliant. I think that's covered everything in terms of those questions. Just want to thank you very much for your time today and providing providing that great introduction source event. Thank you everybody for your time, for attending. As mentioned, that free risk assessment is available. Use the free promo code to get that proof of concept. And obviously, if there are any other questions afterwards, we will be sending a follow-up. Please do feel free to get in touch with us for any more information. Other than that, thank you very much for your time and have a great day, everybody. Thank you.
Thank you.